I would like to go ahead and bring Yogesh online here. Yogesh, you should be able to unmute yourself at this time.
Hello, everyone.
Fantastic. Yogesh here is the principal technical support engineer specializing in Prisma Access, and we will go ahead and have Ramasamy. When Ramasamy hosts next week, I'll give some more information about Ramasamy there, and I will go ahead and stop sharing and hand the show over to you, Yogesh. It's all yours.
Thank you, Charles. All right. Hello, everyone. So my name is Yogesh, and I'm working with the Prisma Access support team. And today we'll be discussing about GlobalProtect and Prisma Access. I have my colleague Ramasamy with me, who's also working with Prisma Access support team. So the agenda for today is we'll do a basic introduction of GlobalProtect and how the gateway selection works. When I say gateway selection, how the Prisma Access, how the GlobalProtect client or app connects to Prisma Access and how it selects the gateway and what are the different modes. Then we'll do a deep dive into authentication, specifically SAML authentication, certificate authentication, and a little bit of authentication cookies and SSO. So first we'll start with the basics of GlobalProtect. GlobalProtect as a client, as an application, is available for Windows, Mac, for mobile, for iOS and Android, and for Linux as well. It's basically a way for you to connect your machine, towards internet. And you do have the whole concept of the zero trust network, where each and every session can be secured through the deep inspection of Prisma Access or Palo Alto Networks. And you can also define specific authentication type, specific authentication rules for critical resources. The basic workflow or the basic component of GlobalProtect application, from the client point of view, it's a client which is installed on, let's say, your Windows or Mac. But the way it works is when it connects back to the Prisma Access, it will establish connection to the Prisma Access portal and to the gateway. So that concept is same as traditional Palo Alto firewalls, where you define a portal and a gateway. However, in Prisma Access scenario, the portals are hosted separately and the gateways are hosted separately. The way it works is the GlobalProtect first connects to the portal. As a user, you would authenticate based on the authentication method defined. Once the authentication is done, the GlobalProtect app will get a list of gateways that it can connect to, and it will match a specific configuration based on the configuration, obviously. And then once that part is sorted, the GlobalProtect client will connect to the gateway. It will do authentication there. And once that authentication is done, it will establish a secure tunnel between the client and the gateway. Here, the communication is either IPsec or SSL. IPsec is always preferred because it's better in terms of performance and lighter compared to SSL. Now, if you talk about in traditional next generation firewall, you have different licenses concept for GlobalProtect. You can configure GlobalProtect portal and gateway without license as well, but there are certain features which require separate licensing. On Prisma Access, however, the licensing model works differently. You get the license based on per user. Let's say it will start with say 200 users. 200 mobile users. So that means 200 users can connect to the Prisma Access locations, and then you can use almost all the features of GlobalProtect. Then based on the bundle licensing, you get different features, different add-on features. Now, let's talk about gateway selection. So when the GlobalProtect client connects to Prisma Access, in almost all the cases, Prisma Access tenant will have at least 3-4 locations defined. It can be within the same country, depending on which country you deployed it in, or it can be across different countries, different time zones. So one of the major concern is how does the GlobalProtect connects and how does the GlobalProtect define or identify which gateway or which location it would connect to. So the GlobalProtect app by design has a gateway selection mechanism when it has options of more than one gateway. By default, it will use the response time. And so, for example, here in this slide, we see the options for the GlobalProtect to connect to US East, US South, and Canada East. The US East and South have both priority 1, and Canada East has a priority 5. Then the next the next criteria is the response time. So the GlobalProtect client will check, and then after with each of the gateway, it will calculate what is the SSL response time. Then based on that, a weight will be assigned. Here, the lower the weight, the higher the priority. So if you see the weight 20 is the lowest for US South, and that's why the GlobalProtect client has selected US South, and it will attempt to establish a tunnel there. This mechanism can be seen in the logs as well. So let's say, for example, you have a user who is complaining that they are expected to connect, and one available mode is selected. We can have the GP client logs. There is a log file called pan GPS, and in the pan GPS log, we can basically see the gateway selection mechanism, the weight assigned to each gateway, the response time, the priority, all of those details. So here we can see that because of the weight selection, the lowest weight was on US South. The client the client selected US South. Remember here, at this stage, the GP has just selected a gateway. It has chosen that the GP will connect to US South. It doesn't really mean that it is actually, it has established the tunnel yet. After this state, the actual tunnel establishment process starts, where the GP will authenticate with the US South gateway or any other gateway for that matter. And it will go through the authentication process and establish a tunnel.
Hey, Yogesh, sorry to interrupt you here. We're getting a little bit of lag every once in a while on your audio. Go ahead and just turn off your camera to free up some bandwidth. Let's see if that takes care of it for us.
Yeah.
I'll let you know if it happens again. Thanks.
Sure. Yeah. Thank you. Now, when we are talking about the gateway selection mechanism, it is a bit simple when you are managing the GlobalProtect on next generation firewalls. You have a bunch of firewalls where the gateway is defined, and the user gets 3 or 4 gateways as an option. In Prisma Access, however, it's a little bit different. When I say it's a little bit different, there are different countries that you can deploy the Prisma Access in, and the GP selection works accordingly to that. So for example, if the first criteria is that the GP will first look at its own in-country location. For example, you're connecting from India, and you have a gateway within India, then that will have the first priority. And out of that, let's say within the same country, you have more than one location. For example, in Australia, you have Australia South, Australia Southeast, and Australia West. So as a user who is connecting from Australia, you get all 4 gateways as your first priority. On top of that, the GP will then take in the priority 1, say, and then calculate the weight, and whichever has the best weight, the GP will connect to that. In Prisma Access, there are some predefined fallback locations, which act as a fallback location for globally. And we can see that in each region. So APAC, Africa, NAM are different gateways. The way this works is, let's say, for example, in Asia, you have Hong Kong deployed in your Prisma Access tenant, and then there are some other locations, let's say India, Singapore, Australia. And then for whatever reason, say the user is not able to connect to their in-country gateway, the user will then fall back to Hong Kong, because that will be available to take connections from any of the locations, irrespective of where the user is. Then if the global fallback locations are not deployed, then there are some additional fallback locations, which specifically for APAC, wherein specifically for APAC, they are India West and Singapore, and then there are some other global locations like Bahrain, France, Ireland, South Africa. So you don't have to configure anything in Prisma Access specifically for this. They're auto-defined. The priority component of the gateway is predefined in Prisma Access. Now, in gateway selection, we often see a problem where, for example, by expectation, let's say user who is in Malaysia, and they do not have an in-country gateway defined in Malaysia, but they have a gateway defined in Singapore location, which is very close geographically. So from the user's expectation, the user would expect that they would connect to Singapore and not to, say, faraway location, which is India. But what happens is by default, because of the priorities defined, Singapore doesn't get a higher priority for the Malaysia user, so they actually get connected to India. There is a way to work around that or modify the configuration in a way where it suits your needs. For example, when we are defining the app settings in the Prisma Access is by default selected, which defines the priorities and locations by default. In addition to that, you can identify the FQDN. Here we are taking example of Malaysia location, and the users need to connect to Singapore location. So you can identify the FQDN of the Singapore gateway, add that as a manual entry in the gateway location. What this does, when the location is connecting to Prisma Access, they get the default list of gateways that they can connect to. In addition, they also get this manual entry. So in the best available method, they have one more entry, one more location where they can connect to. And assuming the SSL response time is better for Malaysian user for Singapore gateway, they will end up connecting to Singapore location instead of say faraway location like India. In the GlobalProtect 6.3, there is an enhancement or a new feature which basically improves the way the gateway selection mechanism works. As we discussed, currently the gateway selection mechanism works where the gateway will try to connect to the gateway will calculate the weight based on the SSL response time and the priority. Priority obviously you can't change, but the SSL response time can be different for different gateways. For example, let's say a user usually connects to their in-country gateway. Say they are in India and they connect to India West gateway, but during the peak hours, because the gateway is as it should with the affected latency, but when it comes to SSL, because SSL needs your certificate verification, the gateway is slower than expected during the peak hours. And because of that, when the GP is calculating the SSL response time, the SSL response time is slightly lower or slightly worse than it is in normal times. And because of that, it gets a higher latency, and GP ends up not selecting that gateway as the best available gateway. With this option, what you can do is you can change that method to use TCP handshake instead. So the GP will not wait for the SSL handshake. Let's say the GP gets a list of 5 gateways. It'll just do TCP handshake to these 5 gateways. and it will calculate the weight based on the TCP response time, not the SSL response time. So that is slightly faster than SSL, and if the gateway is under heavy load, SSL response time will be impacted, while the TCP response time is not that impacted in general. And because of that, the GP can still connect to the primary gateway, the gateway which is closer to the user's location. And then based on that, it can define and identify the correct weight and then connect to the expected gateway. And this feature is available only with the GP version 6.3.1 and above. You do need to enable this in the app settings. Now, talk about GlobalProtect modes. So GP as a client, by default, it will be in the tunnel mode. When I say tunnel mode means the GlobalProtect establishes a tunnel to the Prisma Access gateway, and then all of the traffic by default flows through the Prisma Access, and then based on your configuration, from there the user can access internet or intranet, which is private application, through the tunnel. By default, IPsec is preferred, although GP can connect on either IPsec or SSL based on the configuration. By default, the GP will connect on IPsec. And if for whatever reason IPsec is not available, say your local ISP or your local ISP router or the Wi-Fi that you're connected to has blocked IPsec, GP can fall back to SSL. Comparing IPsec and SSL, IPsec is slightly faster and has better performance compared to SSL because of the underlying protocol. IPsec works on UDP, SSL works on TCP. On top of that, IPsec has slightly lower header size compared to SSL, so it generally works better, and that's why IPsec is always preferred. But in terms of configuration, GlobalProtect has an option where you can define whether it will be in the default state, where it will try to connect to IPsec first, fall back over SSL, or you can define that GP will never use IPsec and only connect with SSL, or the other way around, where you can define that the user has the option, where the user has the control, where within GP client, the user can enable a checkbox. And based on that checkbox, the user can dictate that the GP client will always connect with SSL, or it will not connect with SSL and it will connect with IPsec only. This is useful in cases where, let's say there is a user is in a location where they are using maybe a cafe, they are connected to the Wi-Fi, and then that Wi-Fi doesn't allow IPsec connection. In addition to these modes, you do have a proxy mode available as well. This is a fairly new feature with the GlobalProtect client. The idea here is that there are some environments which are proxy aware, and they support, they have a lot of headless servers or machines or IoT devices which do not allow a direct tunnel, and they might not have routing mechanism or routing configuration where you can have the regular GP tunnel mode, or you're just or a non-proxy based network. During the migration, you still need to work with the proxy vendor or in a manner where the proxy is supported. So there is a proxy mode where you can have the GlobalProtect work only in proxy mode, where the GP will just send out all the internet traffic via explicit proxy. Or you can have tunnel and proxy mode, where the internet traffic is sent out through proxy, and all of your private application traffic is still sent out through tunnel. So for example, you're accessing SMB file shares, or accessing your internal file share, or any other services for that matter, using tunnel, and you continue to access your internet through the proxy. This basically works in a way where the GP client itself defines a proxy on the local system. So you don't have to define any proxy details or any back file in the browser. And then everything is routed through that local proxy to GP, and then GP connects to the proxy, the Prisma Access proxy, and then sends out all the traffic. Now, if we talk about GlobalProtect Connect methods, as you can see, there are various methods: on-demand, user logon, pre-logon. So as the name says, on-demand is when the user needs to connect, and otherwise GP is disconnected. User logon always on means the GP is always connected, which means as soon as you turn on your machine, the GP will try to connect, and it will keep trying to connect to the Prisma Access as it is set to always on. Pre-logon is a specific feature, a specific way of connection where the user there is no user involvement. The GP client connects even before the user has a chance to log into the system. That works in a way where there is a machine certificate installed on the user system. It can be Mac or Windows. And then even before the user has logged on, the GP client will use that machine certificate. And as soon as it has the network connectivity, user has not logged on yet, the GP will establish a tunnel to the Prisma Access gateway. There will be no user there. It will be called pre-logon user, and then you can define policies and access rules based on pre-logon. For example, there are some predefined scripts which needs to be run before the user logs on. So this way the GP can connect before the user has logged on, and log on is done, the user logs in, then the GP changes the mode to on demand, and the user can choose if they want to remain connected to Global, if they want to disconnect for now. Similarly, connect before log on feature is an option where the GP client will connect to the Prisma Access, but it has a user intervention where once the user tries to log into the machine, they will see a prompt where they need to enter their username and password, and there'll be a GP-based, there'll be a logon screen where user will enter the username, password, the connection.